Next up is Andreas Gerstmayr.
Hello everyone. My name is Andreas Gerstmayr and I'm a software engineer working in performance tools at Red Hat. Today I will show you how to integrate BCC and bpftrace tools into a Performance Copilot. Performance Copilot is a system performance analysis toolkit with a wide range of metrics. It supports logging, alerting, visualization with Grafana and much more. BCC is the eBPF compiler collection and it makes it easier to write eBPF tools, and it also has a great integration with Python. bpftrace is a high-level tracing language for eBPF. Performance Copilot supports multiple agents, where each agent is responsible for gathering metrics of one specific domain. For example, we have one agent gathering metrics from the Linux ProcFS file system, another one gathering metrics from the PostgreSQL database, and one for BCC and one for bpftrace. Each metric has multiple metadata associated with it, for example, semantics, whether it's a counter value or an instant, the unit if it's bytes or kilobytes per second, type, and instances. For example, the device throughput metric has one instance for each hard drive. Let's take a look at the code. Each BCC tool consists of two parts, the eBPF code and the Python code. Here we see the biolatency BCC tool, which collects the latency of each block IO request and shows it in a histogram. Here we have one eBPF map storing the start of each block IO request, and here we have the histogram. And now let's take a look at the Python code. Here we have the BCP metric name. It will be bcc.disk.o.latency constructor. Here we have the metric definition. We are storing the values as an unsigned 64-bit integer. It's a counter metric, and it has microseconds. So for storing histograms, we are making use of the instances functionality of BCP. So each bucket of the histogram will be one instance. Here we compile it, and let's take a look how it, how the data will be in BCP. So we can query the data with pminfo -f bcc.disk.o.latency. And here we have each bucket, for example, 16 microseconds until 31 microseconds. This is the counter value. We can also see it in Grafana. We can see each bucket and the bucket values. And we also have integration for bpftrace. The bpftrace integration is conceptually much simpler. You just need to write the bpftrace script, store it in a directory, and then the BCP integration will pass it for variables, for example, the at start and at microseconds, and it will automatically export them as BCP metrics. We can see them. We can see all the exported metrics then with pminfo bpftrace.scripts.biolatency. Here we have some control metrics, for example, the bit of the bpftrace script. And here we have the metrics of this histogram. We can query it with pminfo -f, and we again see the buckets and the counter values. We also can see the bpftrace script output as an histogram in Grafana. We open the bpftrace dashboard, and this is the block IO latency. Here we can see it looks the same as the BCC one, and you can see the buckets and the count, how many values were in this specific range. I hope you enjoyed the talk and you will have a lot of questions in the Q&A and Slack. Bye.
Thank you very much, Andreas. If you have questions for Andreas, please ask them in the Slack channel. Then this has been a perfect example for practical uses of eBPF-based profiling and monitoring.